My dear friends, welcome back to B Spice. In this session, we'll focus on PLC versus SCADA. In fact, this will be the final part of this SCADA series. Okay. In this, what we will discuss about this is we'll focus on the differences, and also we talk about the advantages and a bit of disadvantage, not exactly a disadvantage. Yeah, yes, minor aspects. And finally, we wind up with the applications. So when we talk about the PLC versus SCADA differences, I have categorized some 6 to 7 items. One is the definition. Of course, we all know PLC stands for Programmable Logic Controller. SCADA stands for Supervisory Control and Data Acquisition. Friends, freshers, it's only targeted for freshers. Experienced professionals, kindly excuse me. Okay. And second, design and construction aspects. PLC is like a hardware based, whereas SCADA is more of a software based. And when we talk about the usage and function, PLCs are mainly used to control the process of complex industries like motors, running machines, and all. Of course, not complex like DCS, but yeah, it used to control the process, NONC, on and off, more on a, discrete aspects, digital input, digital output, all those things. So SCADA is used to observe and run the process of the plant. Okay, it's more of a supervisory control, and of course, it acquires the data, right? So when you talk about the components, it includes processor, that is CPU, right? IO modules, and of course a programming device and power supply, all this. When we talk about SCADA, it includes three essential, very simple. MTU or RTU and HMI, that's it, very simple. Master terminal unit, a remote terminal unit, that's it, friends. So when we talk about types, PLC, there are different types, fixed, compact, modular, like that. And SCADA, as you know, right, the previous video talked about, right, monolithic, distributed, networked, and IoT. So when we talk about the IO types, as I highlighted earlier, the input and output are signified in NO, normal, open, and NC, normal, close, and of course as a coil contacts. Here the input and output are SCADA represented through images. That's the thing, symbols, right? Yeah, blocks. So when we talk about the assignment, meaning how the component can be assigned. So every component can be defined through an address, specific address, right? But in SCADA, we have through the name actually. So these are the key critical differences, friends. PLC SCADA. Now we run through the advantages. There are many actually. Of course, the quality of the service, reliability can be improved, maintenance cost is of course less, operations can be reduced. Operations mean operation outage can be reduced, and efficiently we can do. That's my point actually. And large system parameters can be monitored, and manpower, of course, because of the centralized system, and repair time can be reduced, and fault detection and fault localization options are also available. Then few more to add on, it stores large amount of data. That is one of the key advantages. As per the user requirement, it display the data in various formats. If you want a graphical, if you want a data format, all these are options are available. And of course, thousands of sensors can be interfaced with SCADA for controlling and monitoring. Real data simulation can be done by the operators, and it gives a fast response. It's flexible as well as scalable. We can add on extra, right? Yeah, extra modules or extra resources, all this. The SCADA system provides onboard mechanical and graphical information because it brings the plant, the hierarchy, I mean, the plant scenario in front of you actually, using a GUA, a graphical user interface. Okay, friends. So these are the advantages. And a few more to add on. The SCADA system is easily expandable. We can set an additional set of control units and sensors as per our need actually. And of course, this is able to operate in all critical situations. When we talk about disadvantages, there is not much, but we can say it is very complex in terms of dependent modules and various units, hardware units. Not very, it's not a disadvantage, but just for sake of discussion point, I put in here. And of course, it needs some specialized analysts, programmers, and skilled operators. High installation costs, there is no doubt in that. But of course, you can recover. See, ultimately, what we need is TCO, total cost of ownership, right? So even though the high installation cost, we can get the benefit at a longer term. And of course, due to the efficiency, the unemployment rates can be increased because you can within one operator you can control the whole plant, so that replaces the human involvement. This system supports hardware devices, and there is some restriction on the softwares also. These are some of the disadvantages. Then we talk about the application, it's very, 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 very vast. Generation, distribution power, public transport, water sewerage system, manufacturing, industries and buildings, communication networks, oil and gas, of course, and few more to add on: power generation, transmission, water distribution, reservoir, public building like electrical heating and cooling, generator and turbine, traffic light control system, all these friends. Thanks again for watching, and that's the end of SCADA series. Thank you and take care. Bye bye.